Chapter 5, Example 2. The table below shows the results of the top 3 competitors in a recent 3-event competition. Each placed first, second, and third in an event. Who should get the gold medal? The problem here is we have 3 events that we can't really compare. We need to assign kind of points to each one. We want to say which result is the most unusual. Now, this is an important concept. We're going to be talking about z-scores, standard deviation, a lot of stuff here. You need to master this concept. The sooner you have this down, the easier this course will be for you. If I had to pick one concept that is the most important in the first semester, the concepts of this chapter would be that. Finding z-scores, understanding how to use the normal curve. It's critical that you understand this. So to find out who should win the gold, the silver, and the bronze medals for this, we want to calculate a z-score. I want to know how unusual is each score. So I want to know how many standard deviations away from the mean is each competitor in every event. So we're going to find this for the 100-meter dash, shot put, long jump, and then we're going to sum up these z-scores, and you'll see how that gives us a result here in just a moment. For competitor A, they had a 10.1 100-meter dash time, and the mean was 10 seconds. Now, this one is going to be a little unusual because most events, like the shot put, we want to have a positive value. The long jump, we want to have a positive value. For a 100-meter dash, we want a negative value, a smaller value, because a time below the mean is better than a time above, obviously, right? It's the fastest person that wins. When we're doing a distance, it's the one that goes the furthest. So there's a conflict there. In order to account for that, I'm going to take the opposite of my z-score for the 100-meter dash, so I make it a positive score. So I'm going to do negative and then my z-score formula. So negative 10.1 minus 10 over 0.2, which is negative 0.5. So that negative shows that that run time was slower than the mean. Positive value would indicate that it is greater than. For shot put, positives will show a positive distance, so a more unusual positive shot put, a longer distance, and the same thing for long jump. Now shot put, competitor A threw the shot put 66 feet. So 66 minus 60 over 3, which is 2. 66 is the distance they threw, 60 was the mean, 3 standard deviation. So 2, they were 2 standard deviations above the mean, a very unusual distance. For competitor A, the long jump was 26 feet. The mean is 26 feet, but pay attention to these units. The standard deviation was 6 inches. Also, if you look at competitor C, they did the long jump in 27 feet, 3 inches. So we need to convert all these values to inches. 26 feet, multiply that by 12, and you get 312. So for the long jump, we're going to have 312 minus 312 divided by 6, which is 0. Now we're going to add these z-scores together, and we get a sum of 1.5. So overall, the performance of competitor A was 1.5 standard deviations above the mean. Competitor B will do the same thing. So competitor B ran the fastest 100-meter dash time in 9.9 seconds. So we're going to do negative 9.9 minus 10 over 0.2, which gives us 0.5. Competitor B was 0.5 standard deviations above the mean in the 100-meter time. Shot put, so 60 minus 60 over 3, which equals 0. Again, 60 feet minus a mean of 60 feet divided by 3, so 0. Shot put was exactly average. Long jump. Competitor B jumped 27 feet. So we need to convert that to inches again. 26 feet was 312 inches. We're going one more foot, so this should be 324. 324 minus 312 over 6 equals 2. So when we sum these together, competitor B has a sum of 2.5. Competitor B's performance was 2.5 standard deviations above the mean. So competitor B had a more unusual performance than competitor A, largely because of the long jump. Finally, competitor C. Competitor C had a slow 100-meter dash time, 10.3 seconds. So we have negative 10.3 minus 10 over 0.2, which is negative 1.5. So that score is really going to hurt. shot put 63 feet, so 63 minus 60 over 3, which is 1. And finally, competitor C had the longest long jump distance, 3 inches longer than B's, so we're going to have 327. So 327 minus 312 over 6, 2.5. When we sum this together, we get a z-score of 2, a total of 2. So competitor C's performance was 2 standard deviations above the mean. It would appear that competitor B had the best performance, C the second best, competitor A third best. Competitor B has the more unusual overall score and should win the competition. Competitor C would earn silver, and competitor A wins the bronze.